Designing and maintaining a DHCP solution. Now, you should already be pretty familiar with the basic configuration tasks for Microsoft's DHCP server. What we're going to focus on are some of the design decisions that you need to make this a workable part and a reliable part of an enterprise network. With that in mind, here are the topics we'll cover. We'll start by covering some of the techniques you can use to make DHCP more reliable, including setting up split scopes, DHCP failover, which is a new feature in Windows Server 2012, and failover clustering. We'll then talk about some of the techniques you can use to make DHCP a little bit more suitable for a particular environment. We'll talk about the DHCP v6 options, both stateful and stateless design, DHCP filtering, and briefly cover the main DHCP database maintenance task, which is making sure the thing gets backed up. There are certain tasks that you should already be familiar with before you watch this nugget. For example, how to create and configure a DHCP scope, how to create reservations within a DHCP server, how to authorize DHCP servers, and how to configure DHCP supporting services like Pixie Boot and DHCP Relay. If you're not familiar with those tasks, just watch the nuggets that are available for the 70-410 exam. Also, you should already be familiar with configuring and managing failover clusters, and then within DHCP, creating super scopes and multicast scopes, and the basic implementation of DHCP v6. You can find all those topics in the nuggets that are available for exam 70-412. Also in 70-412, you'll learn about how to configure DHCP failover and split scopes. Now, those are topics we are going to tackle in this nugget. We'll primarily look at them from a design perspective. When do you choose to use those, and what are the trade-offs for each of those? But we will look briefly at some of the configuration options for them. Let's start by talking about the first of the DHCP reliability options, split scopes. Now, this is something that you've always been able to do with DHCP. Here's kind of the basic setup. Let's say we have two network segments, which we will designate A and B. We've also got two DHCP servers, which I'll call 1 and 2. Each of these servers is going to get set up to hand out addresses to either of the network segments. So server 1 is going to get a scope that covers network segment A, and let's say that because it's on network segment A, it's going to get about 80% of the addresses for that space. It's also going to get a scope suitable for network segment B, but it's only going to get about 20% of the addresses for that. DHCP server 2 is going to get exactly the opposite. For network segment A, it's going to get about 20% of the addresses, and for B, about 80% of the addresses. Now, there's no automatic configuration of that. You just have to do the math in your head and say, okay, each of these I'm going to hand out about 200 addresses, and so 80% of that is about this many, and so I'll configure those on that server. So here's the operational deal for this, how it's meant to work. When a client requests a DHCP address, that request just flies out onto the network. It's going to go to both DHCP server 2 and via a router that's properly configured for DHCP Relay, the request will get sent to DHCP server 1. Now, the theory is that because the client doesn't have to go through the router to get to DHCP server 2, the request will get there faster, and that most of the time, DHCP server 2's response will come back faster. And so the client will accept that response from DHCP server 2. Now, if DHCP server 2 is offline and not responding, the request does still make its way over to DHCP server 1, and DHCP server 1 will always, even if number 2 is still online, it will always return a response. The trick is that because we've configured them with non-overlapping scopes, it's okay if the client computer gets 2 IP address offers. It'll simply take one of them, respond to that server and accept the offer, and it will ignore the other offer. So even if DHCP server 2 is online, but it's feeling bad that day, it's dealing with a lot of workload, and it doesn't respond quickly, it's okay if DHCP server 1's offer is what makes it back to the client first, and that's the one the client accepts. Now, in a typical environment, you're not going to have your DHCP servers actually on the same segments as your client computers. They're going to often be on a segment by themselves. And so it's possible that your two servers might actually respond simultaneously almost all the time. Well, if that's the case, you just need to change the way you do your setup a little bit. For example, if this is still LAN segment A and this is B, and let's just suppose for a second that our DHCP servers are off on a third network segment in the data center, then I might configure this with half of the addresses in each segment, and I might configure this one with 50% as well. So I'm still splitting the scope so that neither server is capable of issuing an IP address that overlaps with the other one, and which one responds is just kind of be a random guess almost. Now, here's the cool thing about it though. Let's say that server 1 over here, that'll be 1 and this will still be 2. Let's say that server 1 has just been really going at it, and it's handing out most of the IP addresses to the folks on segment A that are requesting them. And it gets to be about halfway through the morning. People are logging on and they're doing their thing, and server 1 runs out of addresses to issue. Well, it's no big deal. Server 2 is still over there. Maybe it's responding a little bit more slowly than server 1 was, but now that server 1 is empty, it will stop handing out addresses for A, and B will start handing them out. But this still provides a level of redundancy, because if server number 2 dies, then server 1 can still take over. Now, if server 2 dies and server 1 is out of addresses, you've got a problem. And so it is important that you be monitoring these things. You really don't ever want them running out of addresses. That's where the monitoring comes into play. So you do need to keep an eye on these. If you're using something like System Center Operations Manager, there's actually a free DHCP management pack you can plug into that so that it can monitor all of your DHCP servers. You can also use Windows Server's IP Address Management, or IPAM, tool to centrally manage multiple DHCP servers. And IPAM is actually something that we're going to talk about in nugget number 9 of this series. So you'll kind of get a better look at multi-server management and monitoring at that time. So this is how a split scope is meant to work, and it's how you're meant to provide some sort of redundancy for these two servers. Let's briefly look at what it actually looks like in practice. So this is the DHCP console for one of my 2 DHCP servers. You can see that I've configured 2 scopes, one for segment A, and this server is intended to be the main server for segment A. And I've got another scope configured for segment B. And this particular server is the backup for segment B. So I want to look at some of the properties for these. Now you can see here that for segment A, I'm issuing addresses from 2 through 100. And the really cool thing on here is if we get over to the advanced side, you'll see that I have a 0 millisecond subnet delay. And that's going to be important in just a sec. Let's compare that to segment B. Now, this is handing out addresses from 101 to 200. And what that tells you is I've kind of balanced a 50-50 split between my 2 servers. But because this server is only intended to be a backup for segment B, on the Advanced tab, I've configured it with a 100 millisecond delay. Now that means when it receives a request from a client on segment B, it will pause for 100 milliseconds before it sends off an offer. I did that because I don't really want this server issuing all of its addresses for segment B. I've got another server that's the main server for segment B. It's configured with a 0 millisecond delay for its main scope, just like segment A is on this server. So when a request comes in from segment B, both of these servers will get that request at about the same time. This server will wait 100 milliseconds before replying, meaning that it's statistically more likely the other server's offer will be accepted by the client. Now, if the other server is dead or offline or runs out of addresses or whatever else, that 100 millisecond delay isn't going to stop things from working. The client will eventually get an offer from this machine, and it will accept it if it's the first one that comes in. So that's another way that you can kind of keep things balanced properly, especially if your 2 DHCP servers are on the same subnet themselves, which is likely to be the case in most enterprises. Now, there's another important thing I want to point out here. Let's take a look inside Scope B. I have a reservation configured in Scope B. You can see it's for a server called Server 17, but pay really close attention to the IP address that's being handed out. It's 10.0.10, which is segment B, .2. If you remember, let's go back into my properties here for segment B. .2 is outside the range of addresses that this server is supposed to be issuing, and that is completely okay. You can have reservations that are outside of your actual scope range. This server will issue that reservation if it's contacted by whatever server this is, and it bases that reservation on MAC address, right? So if I take a look at the reservation itself, oops. I've got a MAC address that's configured to tell it, when this particular server, how to identify that server. So if that MAC address comes along on an IP request, then this server will hand out that address even though it's not in this machine's actual address scope. Why is that? Well, it's part of how split scope works. Let's go back to our network diagram. Remember, when a client, let's say this is the one that I've created a reservation for, it doesn't know it has a reservation. So it's going to send out its request, and that request is going to wind up being received by both of my DHCP servers. Now, ideally, I want this one to be the one that responds, but I can't control that, right? This whole business with split scope just kind of relies on a little bit of randomness and timing. So it's entirely possible that, let's say this server's offline or it's responding slowly. It's possible that this server will be the one that needs to respond. And I need to have the reservation configured on both servers so that no matter which server receives the request from the client, it will get its reservation. And it's completely okay, as you just saw, to have a reservation on a DHCP server that's issuing an address that isn't in the range of addresses that server would normally issue. That's completely okay. The reservation still lives within the scope. It's still a legal address to be handing out for that particular segment. And by having the reservation present on both of my DHCP servers, I am assured that this client will get the correct address no matter which server actually winds up servicing its DHCP request. So what are the downsides of split scope? Well, for one, it's a lot of manual maintenance, and that opens up the room for a lot of inconsistencies. You have to manually set up all of your scope options on each server. You have to manually set up the scopes on each server. If you're going to create reservations, you have to manually set those up. The DHCP servers really don't have any idea that the other one exists. They're operating independently. We're kind of tweaking things so that they won't overlap each other. Microsoft's official recommendation is about a 70-30 split. A lot of folks prefer an 80-20. If you're trying to do better load balancing, it's maybe 50-50. And that right there is another one of the big problems with split scope is you kind of have to fudge around those numbers to get a balance between the two servers that works well because they don't know that the other one exists. So in Windows Server 2012, Microsoft has come up with a new technique called DHCP failover. Now, this is not dependent on Windows clustering. So DHCP failover clustering, we're going to talk about in just a second. This is a new feature. It involves completely separate DHCP servers, same as split scope. The difference is you configure an identical scope with overlapping ranges on each of your DHCP servers, and you tell them about each other, and they replicate information between each other. So you've really got two modes that you can go with here. The first mode is called hot standby. Now in that case, one of the servers is designated as the primary. It responds to all requests for IP addresses, but it still replicates that information to its failover partner. The failover partner is a hot standby. It doesn't do anything unless this one fails, at which point it takes over and starts responding to client requests. Because it knows what addresses the former DHCP server had already handed out, there's no danger of it handing out an address that's already in use on the network. So that's the hot standby mode. The other mode is load balancing mode, in which both servers are actively issuing addresses to clients and they're communicating with one another so that each one knows which addresses the other one has handed out. If you're going to set that up, the real key criteria there is to make sure that those two servers have got a high speed, uncongested, absolutely uninterruptible network connection between them, because it's crucial that those replication traffic bits happen very, very fast. It's very important that each server know in real time what addresses the other one has handed out. The upside of this is that it lets you kind of balance your DHCP workload across a couple of different servers, meaning you can take on more workload while still providing a great level of failover. So again, this is a new feature. This became available for the first time in Windows Server 2012, and it's a much better option in almost every way than split scope. Let's see how you would configure this. It's actually pretty straightforward. Now, I do have a third DHCP server out on my network, so I'm just going to add that to this console. There it is right there. Now, the one thing it's kind of easy to miss is keep in mind that in recent versions of Windows Server, a Windows DHCP server has to be authorized in Active Directory. It's not enough to just install the DHCP feature. So my server showed up on the list because I'd already taken the time to authorize this thing. Now, if we dig into the IPv4 configuration, you'll see that I don't have any scopes set up. That's one of the cool things about DHCP failover. Unlike split scope, I don't have to configure everything manually in two places. I only set it up once, and then I configure failover. So this is telling me that I can configure this scope for failover. We're going to go get the partner server. Let's add a server to the mix here. I'll add this one. Now I get to decide how I want to do this. I'm going to do load balancing mode. I could have chosen hot standby, but because I'm choosing load balancing, I get to actually specify the balance between the two. So let's say I want the local server to actually take on about 75% of the workload. That means the partner server will statistically issue about 25% of the addresses. Unlike split scope, both machines are fully capable of issuing every address in the entire scope. This load balancing isn't splitting the scope. It's actually just telling the two servers about how much workload to take on. So that means my partner server might be doing other work, and I really don't want to load it down with a lot of DHCP traffic, but I do want it to be able to take over if the local server dies. I can have set a switchover interval. I can enable message authentication, which is a shared secret, kind of a password that goes between the two servers. I'm not going to enable that, just to provide better security so that I know no one else is sneaking in on my network and messing up the scopes. But I'm not really worried about that, so I'm not going to turn it on. And configure failover successful. Happens pretty quickly. So now if I refresh this server, get into the IPv4 configuration again, you'll see that that scope has been brought over. It's been given the same name. And if I look at its properties, it should have exactly the same properties. So both of these machines are now capable of issuing the same addresses. Should also have the same reservation. Any changes I make, I should do on the primary server, my local server, this one, and they'll be replicated over to the failover partner. So this is a great technique. Frankly, it's a big reason to look at moving your DHCP servers to Windows Server 2012, because this is such an easy to set up, very straightforward. The servers don't have to be attached to one another in any way except for sharing a network connection. The third option for DHCP reliability is one that's been around in Windows for a while. It looks nothing like this. Looks like this instead. And this is called failover clustering. Now, actual Windows failover clustering is beyond what we're going to talk about here. The presumption is you already know how to set up a Windows failover cluster. DHCP is just one of the services that can live on that. Now, some of the characteristics of this are a single shared storage. This is where the DHCP database is going to go. Two different servers that each run the DHCP service. One of them is active at any time, meaning the DHCP server is actually running. So we'll call this the active node. The other is an inactive node, meaning the DHCP service is installed, but it is not started. So as client requests come in, they go to an IP address that both of these computers share. The active computer actually responds to those requests, accesses the DHCP database, and responds to the client. In the event of a failover, so you've got this extra network connection that sits in between the two, and this carries something called a heartbeat. And the active server is just constantly pulsing out, I'm alive, I'm alive, I'm alive. But if at any point it stops pulsing out the I'm alive, then the other server assumes that the first one is dead and it takes over and becomes active. It starts accepting requests on that shared IP address that they're both configured to use. It starts accessing the DHCP database, and it starts responding to client requests. Because the database is the same one that the other node was using, all the information about the scope configuration, the scope options, reservations, leases that have been handed out, all that information is still there. All the backup node really has to do is start its DHCP service. And of course, you can configure all that to happen manually too. So what are the upsides and downsides of this approach? Well, I think upside number one is that like DHCP failover, you only have to configure everything one time because it all lives in a central database that both servers are using. There's no replication of information because there's only one DHCP database. And that is actually one of the downsides of this approach. There's only one DHCP database. If it gets corrupted, then the entire cluster is useless. This setup is also a lot more expensive to create because you do have to have a little bit more specialized hardware in place. Windows clustering is not an inexpensive thing to set up. It's effective, but you're really only providing redundancy within the servers. Your storage isn't redundant. Now, obviously, your SAN can be configured with redundancy so that if it loses a hard drive, then the whole thing doesn't go down, and that's fine, but you're not protected from a corrupted database. Right? If the SAN is working but the database gets messed up somehow, then this whole cluster is completely useless. DHCP failover, on the other hand, lets you use separate servers. They don't have to have any shared hardware. They don't even have to be hooked up to a storage area network. And you get separate copies of the DHCP database. So you get a little bit more redundancy, potentially for a lower price than setting up a Windows cluster would cost. Windows Server's DHCP service is also fully compatible with IPv6, meaning it supports DHCP v6. There's really two modes in which you can configure DHCP v6. The first is called stateless configuration. In that, on your server, you're only going to configure server options. So any of the server options you want to put in here, your DNS servers, your domain search list, whatever else. You can configure scopes. We'll just put a quick scope in here. When you configure a scope, just like in IPv4, you're configuring addresses. And that means this server will start handing out addresses in addition to your scope and server options. That takes you from stateless configuration to stateful configuration. In other words, in stateful configuration, you are handing out addresses to your client computers. In stateless configuration, The client computers are actually making up their own IP addresses, and that's a completely legitimate approach in IPv6. In stateless configuration, you still have the option of configuring these centralized server options so that you can centrally manage certain aspects of your IP configuration without actually having to manage the IP addresses themselves. It's entirely dependent on how you want to do it. So, once we can put in a prefix here, and this is just the prefix for the IPv6, and I actually need to make that a valid one. So let's see, we need to put in 64 bits, so just make them up. There we go. Now we can decide what our starting and ending address ranges are. Let's just say AA, BB, all the way down to FF. Oops, FF. Click next. We don't need to add any exclusions. Preferred lifetime, the valid lifetime, meaning it's valid for 12, but we'd prefer it only live for 8. And let's not activate the scope just yet, because I want to go in and be able to create some scope options. So you get really the same list of options as you do at the server level. This just configures them for people on that range. Again, in stateless mode, you can set up the scope at all. You just hand out the server options. So IPv6 clients are designed to send out a DHCP request. If all they get back is a bunch of server options without an address, they know, all right, well, I'm allowed to make up my own address. If they get back an address, then that's the one they'll use. So that's the DHCP v6 support in Windows Server 2012. Now, another DHCP technique you've got, and this applies only to the IPv4 side of things, is filters. You have two types of filters, allow and deny filters. And quite simply, let's just set one of these up so you can quickly see what it is. It's just a MAC address. And if you list MAC addresses in the allow side, then only those MAC addresses will be issued IP addresses. If you put MAC addresses on the deny side, then those MAC addresses will be denied. And I guess the neat part about this is you can put in, I got to be careful not to enable this because I don't want to break anything. You can put in wildcards. And you can see it's filled in the rest of the MAC address with stars here. So why might you do that? Well, the first several characters of a MAC address are tied to the manufacturer of the network card. For example, if you were to look at the MAC address for iPhones, you'll notice that all iPhones share a common first set of characters. It's the manufacturer prefix. So by putting in a deny with a wildcard, I can effectively deny all network adapters made by those particular manufacturers. So if you had a network and you needed to lock it down, you're like, look, I don't want any Apple devices on my network. It's pretty easy to set up a deny filter that just denies that manufacturer. Now, the thing you have to be careful with is you have to make sure you're not overlapping too much. For example, Apple makes iPhones and iPads, sure, but they also make laptop computers. And it's possible that because they're the manufacturer for the network card in all of those devices, that the laptop computers might start with the same prefix that an iPhone does. You're going to have to experiment and look before you just go denying something on a wildcard basis. So these are reasonably flexible little things. They exist only on the IPv4 side. Notice that they are server-wide. They do not apply to a particular scope. So if you are going to be setting up deny filters or even allow filters, that's going to affect this server's entire system. All the scopes on this server are going to be restricted by those filters. And the last thing that you're going to need to be aware of is how to perform basic maintenance on the DHCP database. And it couldn't be easier. Click on the server itself, right-click, backup, and restore. So let's just create a quick backup of this. The default directory is under Windows, System32, DHCP backup. It's as good a place as any to drop that backup. And that's it. If it doesn't come up with an error message, then it worked. Let's go in and take a look at the file. So I said C, Windows, System32, DHCP backups. And there they are. Oops. So you just take a look at the dates there and you'll be able to pick out the ones that are the most recent. And if you ever need to do a restore, then you would restore from that file. Now, of course, you're going to probably want to pull that backup file off of the disk and store it on tape so that it's somewhere safe, tape or on another disk. How often do you need to do backups? Well, it kind of depends. Keep in mind that DHCP is a pretty resilient thing. The protocol itself assumes that a lot of things could potentially go wrong. Most of the folks I work with only back up their DHCP database when they have made a configuration change. They've added a reservation, they've modified a scope, maybe created a new scope, or they've modified some of the scope or server options. They don't bother backing it up every day. Because look, here's the deal. Let's say your DHCP server explodes and you have to create a new one and you're restoring it from that database. The database is going to give you all of your basic configuration information. Now, when you go into it, that newly restored database is going to have no address leases in there, and that's okay. Does that mean the DHCP server might start handing out addresses that are already in use on the network? Yes. However, DHCP, before it hands out an address, pings it. Said, hey, I'm about to hand out 10.0.10.3. Anybody using that? Oh, you are using that. Okay, well, I'll mark that in my database as in use. You're going to have to come talk to me at some point, and we'll see if you can keep using it. But I'll keep it in mind for now, and I'll just increment and go with another one. Provided that your network client computers, your clients and your servers, are set up to allow a ping, to respond to a ping, then that system will work just fine. Now, if your client computers are set up to use the Windows firewall, or your servers are using the Windows firewall, and you've locked down ping, then yeah, that can create an issue. And so that's a design decision that you need to make. If you're not going to allow your DHCP server to ping, meaning your clients aren't going to respond to a ping, then you should probably think about backing up your DHCP database more frequently, because that way all of the address leases are something that can also be recovered, and you don't have to worry about the server being able to ping everything. But on the other hand, if you decide that you're going to allow ICMP responses, pings, then your DHCP server can get by with less frequent backups. Now, not so much in terms of maintenance, but more in terms of management of DHCP, be aware that Windows Server 2012 adds Windows PowerShell support for DHCP. So if I run get module minus list available on this server, one of the modules that should, wow, there's a lot of modules. If I scroll up to the Ds, I should see a module for DHCP server, meaning I can use Windows PowerShell to manage DHCP server. So that module is going to exist on any server that has the DHCP service installed. It will also exist on any Windows 8 computer that has the Windows Server or the Remote Server Administration Toolkit, the RSAT, installed. So to get that loaded, import module, just need to get out of select mode. Import module, DHCP server. Now to give you an idea of the capabilities of this module, let's look and see what commands it adds. Get module, get command, module, DHCP server. And it's a pretty big hunk of commands here. You can see looking at the get commands are often the best way to get a feel for what you can do. And there's quite a few on here. And you'll notice that they break down across both IPv4 and v6. For example, if you take a look at the list of commands, let's get a red pen going here so we can see this. We've got a bunch of them that are for DHCP v4, and then you get similar ones for DHCP v6. And then you've got just some generic ones for retrieving the audit log, retrieving an instance of the database. You can run your DHCP server backups right from the command line. So a lot of the management tasks, creating scope options, creating scopes, setting up failover. You can retrieve the failover options there. A lot of this can be automated from the command line. So in a large environment, if you've got many different DHCP servers and you decide you need to do something to all of them, then Windows PowerShell can be an effective way of doing that. Give it a list of your DHCP computer names, for example. Maybe you're going to give it a new scope option that has to be updated, and the command can go out and talk to all of those computers kind of simultaneously, rather than you going around and clicking your way through the GUI to accomplish things one machine at a time. So here's what we covered. We looked at some of the ways to make DHCP more reliable. We talked about how to set up a split scope. We looked at the new failover option, and we talked about failover clustering. The real thing to take away from this is the different levels of reliability that each of those options presents and the different things that are involved in their setup. We also looked at DHCP v6 compatibility, including your options for using DHCP either in stateful or stateless configuration for your IPv6 clients. We looked at DHCP filtering, and I showed you where to go to run a backup of the DHCP database, which is your primary maintenance task. I hope this has been informative for you, and I'd like to thank you for viewing.